Okay friends, so we were discussing about the quantization and I was giving you an example of a fruit vendor. A fruit vendor ke yahan gaye and he told you told him that I want 2 kg of mangoes. But he said that sir, I have boxes of mangoes and I cannot open any of the box. I can simply give you entire box of 10 kg. So he would say that either you will have to purchase 10 kg mangoes or you cannot purchase mangoes from me. So you thought that okay, chalo, let me take 10 kg mangoes from him. Now in the process of taking mangoes, suddenly you get a call from your place and somebody tells you, maybe your mom tells you that there are some guests at home and we will require some more mangoes. So now you tell to the fruit vendor that please give me 5 kg more mangoes. So now imagine what will he say? वो क्या कहेगा? वो कहेगा that sir, I have entire box of 10 kg. I cannot give you 5 kg separate. Either you will have to purchase 10 kg or you will have to purchase another box which has another 10 kg. So the total will now be 20 kg. You cannot get mangoes in any values ranging from 11 kg, 12 kg, 17 kg, 18, 15. You cannot get that. You will have to purchase mangoes either 10 kg or 20 or 30 and so on. So now you might have understood what is the meaning of quantization in general. Here the quantization happened of the mangoes. Mangoes were available in packets, but the smallest possible packet was of 10 kg. In the same way, electric charge is also available in quanta. Quanta, plural of quantum is called quanta. So quanta means small packets, extremely small packets, because the charge is property of the atom. So electric charge, wherever the electric charge is available in nature, that charge always be available in the packets of E. What does it mean? N is an integer value, E is an elementary charge. So if I just write down the possible values of electric charge, then it will be E or 2E or 3E, 4E and so on. I can say that it will be N into E. But again, charge has two types of polarities. It can either be positive or it can be negative. So here the possible values of electric charge can be plus or minus E, plus or minus 2E, plus or minus 3E and so on. So these are the possible values. As you can see, the lowest value in the list is E, which is 1.6 into 10 to the power minus 19 coulomb. So E is now playing the role of that mango packet that I just now explained. It is a packet, it is a quantum, and because the charge is available in quantum, rather quanta, we call this phenomena a quantization phenomena. Are you getting? This quantization occurs for some specific quantities in nature. There are few more quantization that you are going to study in future. For example, you are going to study in your chapter of dual nature of radiation and matter. In that chapter, you are going to learn about quantization of energy. Quantization of energy. You will learn about this formula. The formula is whenever the energy is available. See, let me also tell you the same formula of quantization of energy you will also learn in the chapter of atoms. In the chapter of atoms. So at an atomic level, when different scientists tried to explain the model of atom, structure of atom, it was Niels Bohr who in 1913 suggested two postulates to explain the structure of the atom. Now both the postulates contain quantization of one quantity. See, understand in detail. He said that suppose if this is an atom, this is the nucleus. Now how many orbits are possible? As per the classical mechanics, electron could be present in any of the infinite number of orbits which are theoretically possible for any atom. I have drawn partial part of the orbits. Okay, there can be infinite number of orbits possible. Now scientists were trying to understand the structure of atom, and they were also trying to understand that how or where can electron be present in these orbits. As per the classical mechanics, theoretically electron could have been present in any of this infinite number of orbits. But then it was Niels Bohr who suggested that electron can randomly not be present in any of the orbits. Electron could be present only and only in the orbits which were known as stationary orbits or stable orbits. Stationary or stable orbits, in which if you measure the angular momentum of the electrons, angular momentum of the rotating electron was having this value. Angular momentum, you know that it is denoted by capital L, and Niels Bohr suggested that L could have the values equal to n into h upon 2 pi. What is h, what is 2 pi, and what is n? Here h is known as Planck's constant, which was given by Max Planck, and the value of h is 6.625 into 10 to the power minus 34 joules into second. And 2 pi, pi is a constant, we already know. H upon 2 pi is also known as h cut, which it is also sometimes denoted by h cut, and n is the orbital number. Now, so this means that here h upon 2 pi is the packet, rather it is the quantum, and n can have different values. So electron can be present in the orbits where the angular momentum has these all values. Let us take n equal to 1. So the possible value of angular momentum will be h upon 2 pi, or 2h upon 2 pi, or 3h upon 2 pi, and so on. Basically n will be equal to n into h upon 2 pi. So here the angular momentum is not possessing any random values, but it is only possessing the values in the integral multiple of h upon 2 pi. So this shows us the quantization of angular momentum. Are you getting? Now in the same phenomena, in the same structure, Niels Bohr also had given second postulate. In the second postulate he said that whenever the electron jumps from lower energy state to higher energy state, or when it jumps from higher to lower energy state, while jumping from lower to higher it needs to absorb the energy, while jumping from higher to lower it will emit certain energy in the form of radiation. Now if I am telling you that EI is the energy of the initial orbit, initial state where the electron was present, and EF is the energy of the final state. So EI minus EF will always have the values which are n into HF, n into HF. H again is the Planck constant, as I explained. F is the frequency. Here F stands for frequency of the emitted radiation. Instead of F, sometimes the symbol nu is also used. So energy EI minus EF will be n into h into nu. Now n is again integer number. So what are the possible values of energy which can be absorbed or emitted? The values will be either HF or 2HF or 3HF and so on. So now this HF, the quantity equivalent to HF, is also called 1 photon. The quantum of energy equivalent to value h into f is See, out of these all values, HF is the smallest possible value, and here HF is known as 1 photon of light. 1 photon of light. So there can be energy radiation only in the form of either 1 photon, 2 photons, 3 photons, and so on. Photon is energy only, and therefore here the energy is quantized. Energy is quantized. So we call this phenomena as quantization of energy. This is quantization of angular momentum, and here it is quantization of electric charge. So this is quantization. Now one last point before I end this lecture. See, quantization, the phenomena of quantization can be studied either at the microscopic level or at the macroscopic level. Either at the microscopic or at the macroscopic level. When you study the things at the micro level, suppose if I am trying to zoom in and zoom in, I have an electron microscope and I try to zoom in and zoom in, and I am trying to watch the phenomena which are occurring at the atomic level or at the particle level. So we call it as micro level view, microscopic view. When we try to view the things from higher order, we call it as a macroscopic view. Now there is a statement, there is a VSQ also asked, very short question. They sometimes ask that at the micro level quantization may be important, but at the macroscopic level quantization is not important. Why so? So just look at the explanation now. Let us take a small example. Suppose if there are some cars parked in the parking. This is a car, this is another car, and there are say 10 or 20 such cars which are parked in the parking. Okay, in an open ground the cars are parked. So now you are passing by in an aeroplane, and from the aeroplane when you try to look at the cars, what will you be able to see? See, you are at a very far distance, you are at a height, so what you will be able to see? You won't be able to see these separate cars. You will be able to see a very small view of these cars. Instead of this type of pattern, you might be able to see cars like this. Cars like this. Okay. So this car is seen having extremely smaller size, and now again you are going at even higher level, so it will be like this. You might find them as dots only. Okay, so these dots are there, and when you look at a series of dots from a farther distance, you will find as if they are not separate dots, as if it is a continuous line. It is a continuous line. So in the same way, at a smaller level, when we are looking at the things, when we are looking at the charge from micro level, we might find this is the charge E or 2E or 3E and so on. But when we look at it from macro level, see, the charge is present in tremendous quantity. So in such a high quantity, the quantization does not stand, or rather we can say that there is no need of looking at it from quantization point of view. Hope the concept of the quantization is clear to you. These two topics were actually from the other chapter, but it belongs to the topic of quantization, so I have taken them together. Okay, so now in my next lecture we'll look at the other two properties of electric charge, which are conservation as well as the additivity property. I hope you liked the lecture, understood it well, enjoyed the lecture, and see you in the next lecture. Thank you very much.